All right, welcome back. This is lesson, this is 1.4, which I have listed as good graphs on the website. So this is 1.4, good graphs. All this stuff, these quick notes, they're going to have wrong numbers on them. Sorry about that. But this is 1.4, all about our good graphs, and mainly good graphs dealing with categorical data there. So today, we may have done some social media stuff or talked about something similar where we're collecting this categorical data. And we saw that we have two ways to do it. We can do a bar chart, and that's where we just have the frequency, that's the count, how many of something do we have, and those are the bars. Or we could make a pie chart, and what I didn't note on here, this is relative frequency. So relative frequency, when we think about that, we think about proportions. Or maybe what's more familiar to you is that idea of a percentage. So from this pie chart, we would have that 33% of the class, maybe 33, like TikTok. That's a proportion, right? 33% like TikTok, making up 33% more or less of the pie chart. And so that's how we represent that on a visual representation of the data. With the bar chart, again, you have your two axes, and you're just going to give the normal frequency. You don't really, you can put the relative frequency on here, but it's going to look exactly the same. You're going to have the towers are going to be the same height relative to each other. It's going to be more or less the same. Pie chart you can only do with these relative frequencies. The other thing that we talked about is a pie chart you can really only do in like a computer program. It's very hard to get your percentage and then go, okay, 33% of the circle, that's 360 divided by 3. I need to make this wedge exactly 120 degrees. We don't do that. That's very geometrically involved, and so we don't really bother with that. We just have a computer make it for us. So what's useful to have is this idea of a frequency table, and this was one of our learning targets for the quick notes or the important ideas. We have this. We talk about the variable, and then we can just make a simple tally of the frequency. So if I'm taking a question of what everyone's favorite color is, the variable answers could be blue, could be red, it could be green, yada yada yada, all the way down, and then we just make a simple tally right next to that. Now, say I ask 30 people, and 15 people liked blue out of those 30 people. Well, I can get my relative frequency by taking that number divided by the total. So instead of having just, 15 people liked blue, I can take 15 over the total amount who liked blue, and I can see that, 50% of the class likes blue. And that helps in comparing things that are not the same size, right? If 15 people like blue in a class of 20, that's a lot different than 15 people liking blue in a class of 300, right? If you have more people, you should expect more people to like blue. You should expect that proportion to be the same. So we like talking about proportions, especially when we compare across populations that do not have the same population size or sample size if we're working with samples. Once we have this table, again, we can go into two different ways. We can use the circle graph, what the textbook calls it. It's a pie chart. Or we could have the bar chart. We'll do the bar chart first. With the bar chart, we want a title. We want to label the axes, and then especially important with the bar chart is that the scale starts at 0. So we talked about on the bad graph day, we don't want to be skipping frequencies here. If we start at 6, or if we start at 4, right, it's going to look like Instagram and TikTok are way different than they actually are. They're only really 5 off, but when we move this scale up, when we skip all these numbers, it makes this tower proportionally, this bar proportionally taller than it should be. So we're kind of blowing things out of proportion when we do that. We want to start at 0. There is such a thing as what the textbook calls a Pareto chart. That is just where you organize the bars from tallest to shortest. So you make sure that you put your most popular bar first, and then second popular bar second, all the way down to your least popular. Circle graph always will add up to 100%, obviously. All of your wedges do need labels in some way. So don't just make the wedges and let the graph speak for itself. You have to actually say, okay, this wedge is blue. This wedge is green. You can't just, leave a blank graph. That doesn't mean anything. You can also only use a circle graph when respondents are able to only select one answer. So this might be a little tough to think about, but say I didn't ask you your favorite color. I just gave you a list of colors, and I said, select all the colors on this list that you enjoy. And so some people picked blue and red. Some people picked green and red, green and blue. We had all sorts of different options. Well, when we actually would go to make our pie chart, we would have way more people enjoying different colors than we surveyed. Because if you can answer more than once, then all of the answers on these frequencies are going to add up to more than the amount of people we talk to. So that's going to lead our circle graph to add up to more than 100%. Even if we did balance for that and we're like, okay, we're going to divide by not the amount of people, but the amount of votes, that still really wouldn't work because it's not really fair. One person would have only selected blue, whereas everyone else has the chance to select multiple colors. So only use this when respondents, it's like an or question, when respondents can select one thing or the other. The last thing here is a time series graph. This is kind of like a line chart. I've seen it called that. But basically, it's whenever you have time as your variable. And this is actually a different sort of chart because this uses a numerical variable. So we'll go through an example, but we're going to connect the dots by time, kind of like what we do there. So here's an example of our time series graph. We've got the week, we've got like a distance walked, and our job is to graph that. So you make a little dot, graph these x comma y, right? X is your horizontal, how far you're going left or right, distance up and down. You should be pretty good on that from Algebra 2. But if we need to graph this point, 1 comma 2.1, I'm going to start at 1, I'm going to go to 2.1, and I'm going to put a dot there. Now, you might notice that this scale is not starting at 0. And that's because really when we get to numerical data, we do not need to worry about the scales being proportional. Because numerical data can really start wherever it wants to. A lot of the time, we're not really measuring frequency. There's some exceptions to that. We'll learn about some exceptions next lesson. But with a lot of these maybe time series, this is really a scatter plot. We don't have to worry about starting at 0. It's really only a thing with a bar chart that we have to worry about that. So we graph all those points, and then we connect them up going from left to right. So 1 connects to 2, 2 connects to 3, all the way down. From this, maybe you can see a pattern, is that distance is generally getting greater with time. So this person, as they start walking further and further, they obviously get the ability to go on farther and farther walks. And that's really what the time series graph tells us. It allows us to kind of see a pattern as time progresses. All All right, that's all I got for you. Again, this was lesson 1.4. Good graphs is what it's called on the website, but really it's about categorical charts and that time series graph. All right, thank you, and I will see you next time.